Alrighty, and that recording has started. So, one last time, welcome to the HelioScope webinar. Today we're going to be taking you through how to use HelioScope. And we're going to be doing that with some basic tips, tricks, things that'll make HelioScope better for you, as well as focusing on a commercial, residential, and a ground mount kind of utility scale design. Now, for those of you who have never used HelioScope before, maybe this is your first real introduction to it, HelioScope is a fast, easy to use, and easy to learn design and simulation tool for solar that's still going to get you bankable quality results without you necessarily having to be an engineer. In terms of it being fast and easy to learn, we actually have some of our largest customers telling us that they could take somebody off the street who has no prior experience in 3D design, in solar design, really anything that would apply to that sort of job. They could take that person with no experience and have them trained up and contributing to their team in just about 48 hours. So it's very easy to get people trained up, contributing, and still contributing at a high level to your team. HelioScope's also pretty affordable as well at just $95 a month or $950 a year. And in terms of bankability, when I say bankability, I mean that let's say you need to secure some commercial financing and they want to see your simulations. Well, currently, the only programs that can actually do that are high quality enough to get you that commercial financing are HelioScope and PVSys. And you're going to see that HelioScope is a lot easier to use than PVSys if you've ever used that before. But you didn't come here to hear me harp on about all of this. You actually came here to see how HelioScope works. So let's get started with that commercial design. So to do that, you can see I'm on the home page of HelioScope here. I'm going to click this new project button up here in the top right corner. That's going to open up the project creation page. There are a few things that I have to put in here to get started. So first I'm going to call this my commercial demo. Easy enough, I can give it whatever name I want. And the next thing that I have to put in is an address. Now, I like to separate out addresses into three sorts of categories. The first is just a general mailing address. That's somewhere that you'd be able to send mail. That's somewhere that if you search it on Google Maps, it'll probably take you to the location, to that home, to that business location. But as we know, not all locations are going to have a specific mailing address. Sometimes we're going to be designing in fields or in some remote location that actually doesn't have a specific mailing address. So you can also put in locations with a general address. Things like a town name or a landmark, something that's going to be nearby where you're designing, and then you can actually click and relocate this map, and wherever those crosshairs are centered on, that's where you're going to be designing. Finally, you can also put in your address in latitude, longitude coordinates. So I do have those pre-copied in here just so you don't have to see me painstakingly type them out, but this is going to take us to a commercial building in Kansas City. So now I've got my name and my address, and the next thing that I have to select is my project profile. And technically, I don't have to have one selected. When I'm first using HelioScope, I might actually just have no profile specified. But you are going to have access to our default commercial, ground mount, and residential profiles. What each of these project profiles does is it presets some of the qualities for your design. Things like the components that you're using, or if you're going to be having additional soiling losses, or maybe you have something very particular that you want to model every single time you do a design. Well, instead of you having to set that every single time that you do your design, you can actually just select a profile here. In this case, I'm doing a commercial site, so I've selected default commercial. You can have all those things preset, so it makes it much quicker to actually do your designs. So now that I've got my name, my address, and my profile, I can click Create New Project here, and that's going to take me into the project page. Now that we're here, I want to call your attention to a few tabs in particular. The first being the Designs tab, which we're currently on. This is where we can create new designs, where we can create clones and copies, and also if we need to get things like CAD exports or single line diagram exports, we get that from this page as well. Next is our Conditions tab, and in our Conditions tab, we create what we call condition sets in HelioScope. These represent the environmental effects that impact a array. Things like the weather file that we're using, or if you want to edit your soiling. All these sorts of things you can actually edit in the condition set. And finally, you can go to the Reports tab here. And in the Reports tab, this is where you're actually able to simulate your array and see the production that is from design. Of course, we can't do any of that without actually creating a design first, so let's go back to the Designs tab, and I can either click this blue Create a Design text or this blue New button to open up this pop-up. In this case, I'll leave it as Design 1 and click Create a New Design to get into the designer. Alrighty, let me just check one thing for the audio. Okay, looks like we are still good. Alright, so once I'm in the designer, When I'm in HelioScope or really any top-down design program, the first thing I want to do is I want to make sure that I'm using the correct imagery. And HelioScope by default is going to pull in satellite imagery from Google and Bing's satellite sources. But that said, there's a lot of imagery out there, other imagery that you can use. And the first thing that we want to do is we want to make sure that we're designing on the right sort of imagery. And it looks like this Google imagery is pretty high quality. I can see what's on the rooftop with decently high clarity, but I do have one major issue. And that's that I can see the side of this building. What that means is this image wasn't taken exactly top down. Might not seem like so big of an issue at first, especially for a large commercial rooftop like this, but once I start designing high tilted rooftops, residential rooftops, well, if I can see the side of the building, that means the dimensions won't be exactly true. So instead, I want to get something that's as close to directly top down as possible. So first I can go up to the top the top right hand corner here, and I can click this drop down and I can select Google or Bing, for example. When I click Bing, it gets switched over to that Bing imagery. And as I look around all of the sides of my roof, I can't really see any of the sides of my building. That tells me this is pretty darn close to top down. So this looks like it's going to be appropriate for me to design on top of. But that said, maybe I've got imagery from some other source that I want to see. That is absolutely okay. So if I do want to go and use this other imagery, I go over here to the left, click Advanced Overlays. Again, that's going Advanced Overlays. And I can upload that third-party imagery. So whether you're getting this third-party from just some other imagery provider, a low-flying aerial imagery provider like Nearmap or Pictometry, or maybe you've gone out and you've taken a drone photo with your own drone and you upload and design on that. Or maybe you even have the site plan of a building that hasn't even been built yet, and you've just got that layout. Well, for all of those, you can upload these as an overlay and design on top of them. Because instead of doing your design first and then having to match it to the actual imagery you want to use, find that imagery first, get that correct, and then you never have to go back and redo that work. So now that I've got the imagery that I want to have selected, I'm going to go back to the Mechanical tab here, and I'm going to start drawing what we call field segments. Now, field segments just define where modules are laid out on your roof. They can represent a small portion of it, or they can represent the entire roof if you want to. So if I just wanted to have them represent this northwestern patch of the roof, I absolutely could. But in this case, I do want to design over the entire rooftop. So I'm going to zoom in a little bit more, and I'm going to start drawing out this field segment. So I'm going to click New here. You can see I've got a little dot underneath my cursor, which means that I can start drawing. I'm just going to left click on the endpoints of where I want to add this shape. So I'll make that first left click, second left click, and you can see I can keep clicking. I can either double click or click the original to finish the shape. That said, once I've drawn that first line, instead of me having to go in and meticulously click each one of these points, what I'm going to do is I'm going to hold Shift, and that's going to snap my line automatically to 90 degrees from that line that I've already drawn. So instead of me worrying about if these lines are being placed exactly where they should be, if I'm clicking all these points exactly where I need to be, instead, I can just go through and I can hold Shift, and that'll snap all those corners to 90 degrees. That'll make sure that all those lines are actually perpendicular to one another, so I know that I've drawn out this rectangular rooftop and don't have to worry too much about anything else. So if you do have rectangular roofs like this, I highly recommend, once you draw that first line, using Shift and holding that down to make it a lot easier to draw them out. Now that said, as soon as we finish this shape, you can see that I've got modules populated all the way across this field segment. Maybe we want to change those. You can see I've got these Trina solar modules selected, and those are pre-selected because of the project file that I have. But maybe I want to set something else. So to do that, you see where it says Trina Solar over here on the left in the menu. I'm going to click this drop down, and now I have a few options. First, I can absolutely search through this menu. So if I want to find something else, I can search based on the manufacturer name, based on the wattage, based on the module name, and I can try to find what I'm looking for. But also, if I've favorited stuff beforehand, I can actually just find it in this drop down here, so I don't have to continually search through the database. And let's say I want to use this CSU 320p module. Well, all I have to do now is just click this favorite button, and now all these modules have shifted back to the solar module. Now, I do think favoriting is pretty important, so I'm actually going to put the link for how to do that here, so you can see how to favorite modules and inverters. Because that way, you can go through the library, you can find what you're actively using, and you don't have to search every single time you're in the designer. You just have a select list of components that you know that you use that are your favorites to use, and you don't have to do that search every time. So I've got my modules selected. The next thing we might want to do set our azimuth. Right now I've got that set to 180 degrees, so all my modules are pointing directly south, but I probably want to align these with the building. So to do that, I can edit this manually if I want to. I can set the azimuth to something like 170 degrees. You see that angle corrects a little bit more. But if I have a field segment drawn out, I can also right-click on the midpoint of a design or of a line, and I know which ones the midpoints are because they have these black dimensions hovering by them. I right-click and I say Set Azimuth, and what that's going to do is that's going to point all my modules towards that side of the rooftop. So now they're all pointing towards that southeastern side. If I wanted to point them up towards the northeastern side, I can right-click here, select Set Azimuth, and now they're all pointing up in that direction. So this makes it very easy to actually align your modules with your field segment, with the underlying structure of your building, without having to guess and manually enter that azimuth. Now for the next part of this, I can also enter in a height for my field segment. And I don't necessarily have to. The height, I can model that if that's above the roof. I can model that just at the rooftop. I can model that as the full building. It really depends on how I want to build it out and if I've got obstructions that I want to model or a certain way that I want to show the customer the building. And in this case, maybe I say, hey, there aren't surrounding obstructions, but I do want the customer to see the building in feet. So I'm going to say this building's about 30 feet high. And you see, as soon as I enter that, I have some shade that's being cast on the ground. And that's because, excuse me, that's because we've actually created a 3D shape here. So if I hold Shift, left click, and drag, that's actually going to take me into a 3D view of this array. Again, that's holding Shift, left click, drag. And you can see very, very quickly, I can start designing a 3D object here. I can go in and I can view particular things about my design. So if I've got obstructions that I want to make sure that I've drawn correctly, or if I want to make sure my modules are oriented in the correct direction, well, going into 3D is a very easy way to check that everything is being drawn out correctly. Now, for a commercial rooftop like this, you might not care quite so much about the 3D view, but especially when you're doing residential, tilted rooftops, multi-field segment rooftops, it's really useful to get in here and take a look in 3D. Now for the next part, I might want to change my racking type. So you can see under racking here, if I click this drop down, we have a number of racking options throughout HelioScope. We have fixed tilt, flush mount, east-west, and carport built in as defaults to HelioScope. We've also got an open beta for single axis trackers. So if you would like to go and you would like to test out single axis trackers, you can absolutely do that. Just send us a message at support@folsomlabs.com and we. Now, since this is a commercial rooftop, I'm probably not going to want trackers on top of it. I probably only want fixed tilt or east-west. You see, as I select that east-west racking, I have that nice east-west dual tilt sawtooth, whatever you want to call it, racking all the way across that rooftop, switched instantaneously. But for now, just to keep it a little simpler, let's go back to the fixed tilt racking layout. Now, I can also control the tilt of my modules. Right now, that's set to 10 degrees, but if I set that a little bit higher, see, I've got that 60 degrees. And granted, we're probably not going to put our modules at a 60-degree tilt on a rooftop like this, or potentially ever, unless we're up in Alaska or something. But it is just to show you that we are modeling those effects. And let's set that back to a more reasonable 10 degrees for now. Now, for the next part of this, I think I want to go and I want to set my row spacing, but it actually might be a little bit hard to see from this view. So instead of me trying to do this in 3D, what I can do is I can go up here to the top right and I can click this Recenter View button. And that's going to take me back to that 2D top-down view. So no matter where I get to in 3D, no matter how lost I might feel, I can always click that Recenter View button to get back to that 2D top-down view. So let's set that row spacing now. I can set this manually like those other values. I can set it to something like 2, 4 feet if I want to, and I can also set I can also set smaller values. They don't all just have to be whole numbers. But if I have the ability to play around a little bit, I can also use the calculators that we have pre-built into HelioScope. So you can see I've got this blue text next to Spanderize and GCR. If I click that blue text, I can open up that value, and I can put in a value for Spanderize or GCR that I think is appropriate for me. HelioScope's going to take into account the spacing in between your rows. It's going to take into account the tilt of your modules, the orientation, the location that you are on the globe. It's going to take all of that into account to give you the appropriate row spacing, to give you that Spanderize, to give you that GCR value. Now, if you can play around with your row spacing a little bit more, we also have this time of day tool. Now, before I show you, I will just sort of put in a word of caution. If you're using ballasted racking, I'd recommend talking to your manufacturer about what that row spacing can be for the ballasted racking product. because a lot of times they'll have it restricted to say, well, you can have these tilts and you can have this row spacing. So always reasonable to consult your manufacturer before you actually go in and start playing around with ballasted row spacing. But that said, if I do have the ability to play around with this, I can click this blue time of day text, and that's going to open up this time of day analysis. What it says is, by default, between the hours of 10 a.m. and 2 p.m., I do not want my modules to shade one another. Now, I can the date of this, I can click this calendar button and select a different day, and I can also make this time window larger or smaller if I want to. But by default, it's going to be on the winter solstice between the hours of 10 a.m. and 2 p.m. And you see when I run this, I only need about 1.5 feet of row spacing in between my to not have them shade one another during that time window. That is a lot of saved space on the roof. I don't have to do 2, 3, 4. I can get 1.5 feet in between my modules, and now I can fit a lot more into this space. And let's say that we set our modules to a more crazy tilt, something like 60 degrees a day, again, and run time of day shading one more time. You can see now I've got to a 7.7 foot row spacing. And that's because at 60 degrees, I'm going to need a lot more space in between my modules to make sure that they don't shade one another during that time window. So let's set that back to a more reasonable 10 degrees and run time of day shading one more time to get back to that nice 1.5 foot row spacing. Now for the next part of this, I can also set my setback. So you see I've got an orange border around the edge of my field segment. That's 4 feet right now, but this is a commercial rooftop, so I might want something like 6. And you see that gets a little bit larger, and it just means that no modules are going to be placed within 6 feet of any edge of my field segment. Now for the next part of this, I can change my alignment settings. Right now I've got all my modules laid out in sort of a justified grid alignment, but if I want those to be aligned all the way to the right, all the way to the left, or centered, all those 3 options are going to try to fit as many modules into that space as possible. But for now, maybe I don't have this absolute grid layout, so I'm going to select that, and instead of using the alignment to shift these around, I'm going to zoom in a little bit, and I'm going to right-click and select Align Modules to click. That's going to put a few more modules into that space. It's going to change where that underlying grid actually is on top. Now I can see I've pretty much used all of this available space, so we know that we've laid out our modules correctly. It's time to move on to defining our obstructions. To do that, I'm going to go to the Keep Outs menu here, and we can see that we do have some obstructions on the rooftop, but it's a little bit hard to see them through the modules. That's okay. I can go up here to the top left, and I can click this Showing Array button to remove those modules from the rooftop. Then click it again, they'll reappear. So let's hide those modules for now and start designing some of our obstructions. I'm going to zoom in on this HVAC unit here, and just like drawing a field segment, I'm just left-clicking that first point, second point, and this is a rectangular obstruction here. So I'm just going to hold Shift and then double-click to finish that shape. Now we can call this an HVAC unit if we want to. We can give it a setback. We can even give it a setback of 1 foot, not 10, and a height of 5 feet. And now I've actually got this HVAC unit on my rooftop, and it's going to affect my modules. It's going to have some shade. It's going to make sure that no modules are placed in that area. And we have this one design, but we notice we have 4 others just like it all the way across the rooftop. Now, instead of me trying to design each one of those individually, instead what I can do is I can make sure that I have this mouse cursor button selected. I can also hit Escape, by the way, to deselect that, but I have my mouse cursor button selected, and I'm going to hold Alt, or if I'm on a Mac, I hold Option, left-click, and drag. Again, that's holding Option, left-click, and drag when I have that mouse cursor button selected. And now I can move these copies of these keep outs exactly to where I want them on the rooftop. So instead of me having to draw this HVAC unit 5 times, I can draw it once, and then I can copy it over to exactly where I want it on the roof. And these all have the same dimensions, the same setback, the same height. It's all going to be the exact same. So it makes it very easy for me to design these similar obstructions in a short amount of time. Now for the next part, we can see that we have a large number of skylights on this rooftop, and given their layout, I probably don't want to put any modules in between them. So instead what I'm going to do is I'm just going to draw an area around these to remove modules. So I'm going to click Keep Out here, click my first point, click my second point, then I'm going to hold Shift and come down to have those nice 90-degree angles, since this is a nice rectangular shape as well, and double click to finish it. Now you see as soon as I finish that shape, it is going to copy over that same height and setback from what I did before. And this works all the way across HelioScope. So if you are designing a field segment, if you're designing a keep out, if you're designing a wiring zone, we're going to copy over the previous values from the one that you were designing so that you don't have to re-enter them every single time. In this case, though, I just want this area where I don't place any modules. So I'm going to set that height to 0 and that setback to 0 as well. And now if I click that hiding array button up there in the top left, you can see that our layout has updated. There are a few things that maybe we want to change about this. First, if we were looking at the dimensions as we were designing, we noticed that we definitely need a north-south and east-west access path for this rooftop fire code compliant. And we've also got this long column of double modules right here and a few rows down here where maybe we want to put electrical equipment, and this isn't particularly friendly for ballasted racking. So let's just remove those as well. Now to start off, let's add in that north-south access path. So I'm going to make sure, I'm just going to click up here and then double click down here to create what we call a straight line keep out. So this is just a straight line all the way across our roof. But let's say we want this to be a 4-foot access path. It's going to have 4 feet. I'm going to make sure that no modules are placed there. Well, I can give myself a setback of 2 feet. So that's 2 feet on either side. And now I know that I have this absolute 4-foot access path all the way across the rooftop. Now for the next part, we do need an east-west access path. We also want to change how some of these modules are laid out over here. But instead of overcomplicating our rooftop, instead what we can do is I'm going to make sure that I have this mouse cursor button selected, and I'm going to click this old keep out. And what I can do is I can just change where these endpoints are on the keep out. I can drag these to exactly where I want them to be, remove the modules that I don't want to have on this layout. And now I'm not overcomplicating my layout. Excuse me. I'm not adding additional keep outs. I'm not drawing too many objects. I can just have this one that's removing all the modules that I don't want. And let's say I make a mistake. Let's say I drag this off the rooftop. I do something with it that I actually don't want to do. Well, that's okay. I can always go up here to the top left, and I can click this back button. So we actually have a multi-step undo and redo function in HelioScope. So it makes it very easy for you to go and test things out. Or if you make a mistake, it's easy to recover the work that otherwise we might have lost. We do have that undo and redo. So now that I've got this drawn out, awesome. I think we've drawn our access paths across the rooftop. We've removed some of those modules that we don't want. But what we also notice is currently we're removing modules that are in shaded areas. And that's because at the top of the keep outs menu, we have this keep out from shade checkbox selected. Now, if I click this blue text here, I can go in and just the same way as the day row spacing, I can set a date and a time window that's going to cast the shade on the rooftop. But the thing is, that's kind of an old way to estimate shading effects. People would say on the winter solstice, if these modules are shaded during this time, I don't want to place them on the roof. But that's kind of an old assumption, and it also isn't necessarily going to consider how our modules are truly performing on this rooftop. So instead what I want to do is I'm going to uncheck keep out from shade, and that's going to place modules in all those shaded areas. Now what I'm going to do is I'm going to go over to advanced shading, and I'm going to click calculate shading. And what this is going to do is this is going to calculate the shade loss for every single module on our roof for every hour of the year. And we can see now our total shade losses actually aren't too high. They're only about 0.9%, but our worst performing modules are losing 30% of their energy due to shading effects. And that's pretty high. That's something that can lead to mismatch effects with our stringing. We probably want to take that down. So instead what I can do is I can drag this bar and I can start making it a little bit lower. And as you see, as I start lowering my module shading cutoff, more and more modules are removed. If I take that all the way down to 10%, I say that no modules that lose more than 10% of their energy due to shading effects be laid out on my roof. Looks like there are only 8 modules that need to be removed from this rooftop. And we remember how many were removed beforehand. In the shade path even, where all those modules were being removed from. But it turns out, if we just have that shading cutoff of 10%, we only need to remove 8 modules. And that means we can fit in a lot more power on our rooftop, particularly if we have one with a lot of obstructions. We can actually analyze the from those modules instead of just guessing at it based off of the shade that you see for a single day. Someone asked about parapet walls. So for parapet walls, we don't have a direct adder right now, but what you can do is you can just go in and add those as single line keepouts in the keepout menu, and then you can just give those a little bit of height. Say, okay, my parapet wall is 1 foot, 2 feet. Well, draw out that line, give it 2 feet, and then draw out those other parapet your rooftop, and you can see those effects. I won't do that right now in the webinar just because we only have so much time, but that's how you would add those in. All right, so I can click this Remove Shaded Modules button, and that's going to remove those modules from the design. If I want to add them back in, I can right-click here, and I can select Restore Modules to add all those modules back at once. Now, one last thing that we can do is we can go over here to the Keepouts menu, and if there are any stray modules that don't quite work with our design, we can right-click to remove them, or we can right-click to add them back in. So I'll right-click to remove this last module, but I think that's a pretty good layout for our rooftop. We've got our shading considered. We're maximizing our space on this rooftop, so let's go to the electrical section now. So I'm going to click into electrical, and you can see based off of the project profile that we have selected, we already have these Sunny Tri-Power inverters selected. But maybe I want to use something else. Maybe I want to use something a little bit larger. And in this case, let's say I want to use a 30 kilowatt inverter. So I'm just going to type in 30K, scroll through here, and maybe select something that comes up that I think will be good. So let's try this inverter. And you see it's going to get us to about a 1.21 DC-AC ratio. And that's because currently we have a set DC-AC ratio that we're trying to hit. Now, if I click this blue text here under count, I can manually set the number of inverters that are going to be in my array, but I can also set the number of inverters based off of a target DC-AC ratio. So if I click this blue text again, you can see right now that's at 1.25, but if I want to make that DC-AC ratio larger or smaller, I absolutely can. So if I want to set that to 1.5, just 1, I can absolutely do that, and HelioScope is going to get as close to that ratio as possible without going over it. So I'll leave that at 1.25 for now. We'll still have those 11 inverters. And the next part might be a little bit hard to see from this view, but I'm going to click this SLD button up here in the top right, and that's going to bring us into our automatically generated single line diagram. So as I've been doing all of this designing, selecting my modules, my inverters, well, this single line diagram is being generated as well. Or has been generated. Excuse me. So this updates dynamically. If I change any of those things, well, this will change with it. For example, if I want to add combiners to my design, if I click this blue text here to add those, you can see those appear in my single line diagram. And now I can also see the conductor that I'm using. I can see that here and in the wire schedule, and I can see it in the home runs. And I can see I've got about a 1.9% voltage drop. So maybe I want to make that a little bit bigger, set that from 12 AWG to 8 AWG, bring that down to a 0.7% voltage drop, and you can see it updates in the single line diagram as well. And if I want that removed from the design, well, I can just click X remove here and take that out. This is very easy to go through to edit, and if you want to export this, make some additional edits to it, you can always click this Export DXF button up here in the top right, or you can right-click in the middle of the page and save it as an image. Now, going back to the map view for the next part, the next thing we have to do is we have to set our target stringing range. Right now, we've got a suggested range based off of local ASHRAE data. So HelioScope is pulling in local ASHRAE data, and based off of the local maxima and minima temperature, as well as some of the conditions for the components that you're using, we're giving you a suggested stringing range. Now, that said, you don't have to stay in this range. If you need to go above it or below it based off of the recommendations from your manufacturer or based off of your own calculations, you absolutely can. This is just a recommendation from these temperatures. But that said, it probably is a good idea to set your string length. So while this is 9 to 11 module range, instead I think I want to set a single string length. So I'm going to click this blue set manually text here, and I'm just going to go through this range and maybe bring it down to 9. And this means that all of the strings on my rooftop now are going to be 9 modules long. Now what's important to note is you can see down here in the bottom right hand corner, I've got about 5 modules that are not being run. And that's because the total number of modules on my rooftop is not evenly divisible by 9. So if your total number of modules is not evenly divisible by your string length, well, you're going to have a few modules that are cut out. So it's always important to consider that. But I think for now that's going to be okay. So we've got our mechanical, our keepouts, and our electrical designed. I can just click Save and Exit here. Go to Reports, click Simulate, and that's going to simulate the production for every single module for every single hour of the year, and it's going to do all of that with PV-SYST quality. So that's commercial, bankable quality. But it's going to do it in a lot less time and with a lot less manual finagling than something like PV-SYST do. So even though this is 400 kilowatts DC, you can see this completes for me in just a few seconds. And now that that's done, let's take a look at the report that it's generated. At the top, we have some of our critical information listed. Things like our module DC nameplate, our annual production, our performance ratio, our total kilowatt hour per kilowatt peak. Now, if I want to print this out, I can click this PDF button at the top of System Metrics, or I can click this printer icon up here in the top right. If I want to update my logo, if I have a different one, or if I haven't even uploaded one, I can click this Update Logo button here and upload that logo. And I want to get an 8760, so if I can get hourly production for my design, I can click the CSV button and download that right here. And we did have a question. I apologize for slightly skipping over that. Someone asked, how would I work with microinverters? Well, we'll actually kind of go over that for the residential portion of the design. Just wanted to let you know that we are going to touch on that later. Scrolling right along, we've got our monthly production chart here. So if I hover over individual months, I can actually see their production, or I can click this blue text here to open up the table, those table format, and I can hide it away just as easily. Now, I used to be a commercial system design engineer. So what I really like is this sources of system loss chart right here. In fact, I think it's probably the most valuable part of the simulation of this report. And that's because it makes it really easy for you to go through and for you to identify what is going on with your design. And you can see right here, I've got 7.4% inverter losses. These power losses due to inverter efficiency, now I maybe can't do too much because of that. That's just something that is additional inverter. But maybe I can select a different inverter. And so without me having to go through and do any complex math, to go through tables and try to figure out what's going wrong with me, I come here and I can see I've got 7.4% loss due to my inverter efficiency. I might want to select a different inverter. And it's that easy to come in and see where your design can be improved upon, where mistakes might have been made so you can catch them and you can deliver that best for your business and that best design to the customer. Now, if you're used to using something like PVSys, we've also got this annual production table right here that has those losses listed out in order, and you can hover over these values too to get a little bit more information. For instance, for constrained DC output, I can see if I've got overvoltage, undervoltage, overpower, or underpower situations for my array. I've also got my condition set right here, so all of my assumptions from my condition set listed out. I've got a nice sort of little bill of materials here for my components, my inverters, my strings, and my modules all laid out. And if I click this blue text here, I can open up a full electrical characterization for each of my components. And at the very bottom, I've got a nice detailed layout of my array. So I can see that on the rooftop, right now I've just got the modules set to appear. I've got my logo down here in the bottom left-hand corner, but if I want something else to appear, I can click this drop down next to download, and I can select other things to appear and then re-export the image. Now, all that said, we realize that we probably want to select a different inverter. So let's go back to the designs. I'm going to click new, but I'm not going to do a completely new design. I'm going to select a design to copy. So I'm going to select design one here, and let's call this one new inverter. I'll click create new design, go in there, and now I don't have to do any additional design. I've drawn out my modules. I've drawn out my abstractions. So now I can just go to electrical and select that new component. Now there is one here that I know that I should probably use, and I also know it's got a relatively complex name. Now, instead of me trying to go through and trying to type out that name specifically, I can actually search for little characteristics of the name. That's going to get me to that name a lot quicker than the full name might. So if I click in here and I say, well, I know it's going to be a 30 kilowatt inverter. I know that it is a US TL10 and it's an SMA. Well, it turns out that the full name for that is an SMA Sunny Tri-Power 30,000 TL-US-10. That is a mouthful. And it also means that if I type something wrong, if I take out a zero or leave out a hyphen, I might not actually find what I'm looking for if I try to type out that full name. But if I type in little characteristics of the name that I know are there, you can see I've only got two options here. They're both SMA, and it makes it very easy to find what I'm looking for. Now, this is still a 30 kilowatt inverter, so we've still that 1.21 DC-AC ratio, but we do have a warning down here. Low VMP at high temperatures. And that tells me that my string size is probably a bit low for this inverter. So I'm going to click this blue set from temperature text here. And now we've got a new range, 11 to 19 modules. So I can go in here and set this manually, and I can just bring this string sizing down a little bit. Maybe bring it all the way down to 13, say this is 13 to 13. And I do lose a few more modules down here in the bottom right-hand corner, but I think the improved efficiency is definitely going to make up for it. So I can just click save and exit, and that is all I had to do to change out a component. And this is the solar industry. We get orders all the time. We get people asking for different modules, different row spacing, different inverters, asking what would happen if a tree were there or weren't there, if a building goes up next door. And the thing is, with HelioScope, you can design those situations quickly and efficiently and without actually ever having to leave the customer or send this back to engineering. You can just go in and say, okay, we've got a building next door. Let's see how high that's going to be. You want a different row spacing? Okay, I can copy for you, do that. it's very, very easy and efficient to make these changes, and now you don't have to worry about all that go-between between the salesperson and engineering and the customer. Now, while we're out here, let's also go to the Conditions tab, and HelioScope automatically pulls in the nearest available weather file for your condition set, but maybe we want to select something else. So I click this New Conditions button here, and I can select a different weather file, and also make different assumptions for this new condition set. So in this case, I do have this TMY3 file, which is close to where I'm designing, but maybe I want to use this TMY2 file. So I can select that. You can see that the blue flag updates up here. It's about 15 miles away from my site, but now I'm using that TMY2 file. And let's say we also want to consider some snow losses. This is Kansas City. We're probably going to get a little bit of snow in the winter, so I'm going to go to soiling here, and I'm going to start adding those in. 15% for November. Let's say it gets worse in December, gets worse in January, and then trails off again through February and March. And just like that, I've added in those additional snow losses to my site. And I can go through and I can really get in depth about this. If I want to have a different weather file, if I want to select different soiling, if I want to go into my mismatch or my cell temperature modeling, I can absolutely do that. And I can get really in detail about what I want to do. So you can see this isn't just necessarily a sales tool. This is also an in-depth engineering tool if you need it to be as well. Let's call this my TMY2 with snow and click Create New Condition Set. Entirely new condition set. Someone did ask, and by the way, I'll go back to the Reports tab, and now I've got 3 new reports to simulate. Somebody asked, can I import meteor data into a project? Absolutely. So I'm going to send the link for how to upload weather files into HelioScope chat, and you absolutely can do that. So if you've got your own custom weather data that you want to upload, you can absolutely do that. You can get that, and you can simulate with it. You can see, even though this was another 3 reports, all 400 kilowatts in size, they're all pretty much done simulating in just a few seconds. And I can compare these on face value by kilowatt hour per kilowatt peak, by performance ratio, by total energy production. But it looks like as we look at all of these, our new inverter is definitely outperforming our old inverter. So instead of me having to judge based off a few other things, I can just say, hey, this new inverter is outperforming my old inverter. If it's cost comparative, let's use that new one. And the same thing for our condition sets. Even though it's got those high snow losses, that TMY2 file is still outperforming our TMY3 file. Now, maybe that's because it's 15 miles away. Maybe we want to take a weighted average or something between the 2 weather files, or trust one over the other. Whatever we want to do, that it's easy to compare and contrast with HelioScope and still get that best design to the customer. Now we're going to go right into the residential demo. Y'all have been asking great questions so far. If you do have any additional ones, please feel free to put those into the chat. But I'm going to go back to home, click New Project. Let's call this our Resi Demo. And I'm going to take you to a house in California, 295 Atherton Avenue. And I'm going to select our default residential profile. So I've got my name, my address, and my profile. My map is centered where I want it to be. I'll click Create New Project, and then New, Create New Design to get into the designer. Now, the first thing that we always want to do when we are in HelioScope, again, in any top-down designer, is we want to make sure that we've got the right imagery selected. And it looks like this Google imagery is okay. I could definitely design on this rooftop, but it looks like this is a pretty affluent neighborhood. Maybe I want some higher quality imagery for this site. And let's take a look at the Bing imagery then. Google's going to be okay, but I could probably do better. Let's select Bing, and you can see that's a little bit better. But if I'm going to be designing on these 2 southern-facing roof segments, it might not be high quality enough for me. And this is where that high-quality flying aerial imagery or that drone imagery or that site layout does come into effect for overlays. It makes them really, really easy to go in and get the quality of imagery that you want. And in fact, if you already have a subscription with Nearmap, we actually have them integrated directly into HelioScope. So if I click this dropdown, you can integrate this, and I can select Nearmap. So now I can just have that Nearmap imagery selected. And you can see it's a vast improvement in quality. And this makes it really easy for you to go in, do the design on your rooftop, and you can also catch really tiny details. Things like obstructions, tiny pipes that you might not have seen that would mean that you couldn't place a module somewhere. Well, you can absolutely see those with that's this high quality and still not have to visit the site. So I'm going to be designing on these 2 southern facing roof segments. We had another question come in, someone asking how often are major components updated. So we update our component database regularly, and in fact we have regular updates every either twice a week or once a week depending on how busy things are getting. But you can always send us the data sheets for whatever you want to have uploaded. You can send those to support@folsomlabs.com, and I'll put the email for that in the chat. So you can send us those data sheets and we will upload those additional components to HelioScope. So we're always uploading new ones, but if we don't happen to have the one that you're looking for, we will upload that quickly to the database. So now let's start designing on these facing roof segments. A little bit more here, click new on my field segment and start drawing this out. Now, I can hold shift, it looks like all of these angles are at about 45 degrees. So this makes it very easy for me to quickly find this gutter line. But we notice that it's not exactly the most friendly gutter line for a rooftop. In fact, it's a little bit tricky. And if I had something that was maybe obscured by trees, if I wasn't particularly confident in that gutter line, I might think, I want to set the azimuth for this roof. For flush mount racking, you can actually set the azimuth based off of the top edge or bottom edge of your rooftop. So right now you can see they're pointing directly south, but I've got this nice long ridge line for the rooftop, so I can just right click here, and now my alignment options are set to top edge or set to bottom edge. In this case, this is the top edge of my rooftop, so I'll set this to the top edge, and now you can see that that's pointed, that's the top edge of the rooftop, and this is all done automatically. Let's even give ourselves a little bit of height here, bring this up to 10 feet, and you can see that because this is using flush mount racking, I actually have a tilted 3D segment that's being created here. Let's say I set my tilt to something crazy, like 40 degrees. You can see this tilt actually increases, and it also increases the shade that's being cast from this rooftop. Now, this might not seem too important at first, but especially when we've got large residential buildings, or we've got different heights to our rooftop, we've got different stories, and maybe we're going to be placing modules in some areas where one story would be shading another. Well, we want to consider that. We actually want to know the effects from the shade of these various roof segments. And HelioScope's going to let you do that. So let's set that tilt back to a nice 18.4 degrees, and I'll recenter the view to get back to that 3D top-down view. Now I think I can fit a few more modules into this space. First thing I'm going to do is I'm going to come down to these automatic layout rules, and I'm going to change our default orientation from portrait to landscape. Someone asked, preference between portrait and landscape. You can absolutely set that in your profile, and you just saw I can switch between those very easily as well. Now the next thing I'm going to do, because this is a residential rooftop, I'm going to try to tile this to fit as many modules into the space as possible. So I can just click this centered alignment here, and that's going to tile these modules out. Now you can see I can fit a few more into this space, and they're going to be tiled so they actually center into this rooftop. Now, that said, maybe I have some cases where I want to lay out modules that are in mixed orientations, or I want to edit exactly where the modules are going to be on my rooftop. I've got some interesting particular places where I need to put these modules manually. Well, to do that, I've got these manual module controls here. And I can lay out modules both in portrait and landscape orientation. I can lay them out in groups individually, and I can edit the position of modules that already exist on my roof. But you can see, if I needed that mixed orientation, I can just come in here and I can also hold shift to snap to the existing grid, and I can lay out modules in that mixed orientation across my roof. So it's very, very easy for me to come through and for me to actually manually edit and place modules exactly where I want them. In this case, I think that our automatic layout is doing a pretty good job, so I'm just going to click this red button here to undo those manual changes. What we realize is we also want to put some modules onto this area as well, this other southern facing roof segment. So I'm going to go up here to the top left, I'm going to click back to list here, and now I can actually draw out a new field segment. So if I click new here, I'm just going to click this left point here, click again, and double click this last point, and that's going to complete the shape, and this copies over all those previous values that I designed. So it's still centered, it's still tiled, it's still got that same roof tilt as well, and that same height. So all I really have to do for this roof edge now is I don't have a ridge line, so I'm going to have to set the azimuth. But I'm just going to right click here. This is the bottom edge of my rooftop. I set this to the bottom edge. And it looks like our heights are a little bit different. So I'm just going to go into 3D here, and I'm going to edit this a little bit. Maybe set this to 11 feet to get those ridge lines to line up better. Now, if I recenter the view, I can see I've got these two separately facing roof segments drawn out here very quickly and very easily. Now, it looks like, let's see, okay, moving right along. The next thing we might want to set is the setback for a rooftop. And to do that, for a residential rooftop, we're actually not necessarily going to have the same setback on every side of our roof. So instead, we're going to add those in with straight line keepouts. Just going to go to keepouts here, click this first point, and double click this second point to create a straight line, give it a setback of about 3 feet, and now I can add in other setbacks all the way across my rooftop. Next thing to consider is I've got a lot of trees around my roof, and I can add in trees in a few ways. First, if they've all got just about the same height, I can actually just add those in with a general cutout shape. I can say, hey, these are all going to be about feet, and if you've got a forest or a copse of trees, an area where the trees are all going to be about the same height, well, this is actually a good way to model them, because the variation of 1 foot or in one direction or another isn't actually going to matter too much for the shade that's being cast on your modules, if it's going to be a large group. But when you do have individual trees that matter, well, you can actually add those in with this tree shape. So I just click tree up here at the top of keepouts, and I can click on the center and then drag that out and left click when I've got to the appropriate diameter of the tree. And you can see I can add in these trees that are going to be casting a lot more shade. I'm going to uncheck keep out from shade to make sure that modules are placed in shaded areas. But you can see now, admittedly I have to go through this relatively quickly because this is a webinar, we only have so much time. But I can draw out a really intimate 3D design for this rooftop. And that means that if you are trying to design something remotely, if you've just got an image, you can actually do that with HelioScope. And NREL validated last July that you can actually do quality shading analysis with HelioScope, remote shading analysis, that's going to be the same quality as LiDAR or better in pretty much all cases. So you can actually go in here and all you have to do is have one image of your roof. When that image was taken, but then you can figure out the exact height of all your obstructions, the tilt of your rooftop, the height of your rooftop, all those things with just a single image. And that means you don't have to do a truck roll, you don't have to get up on top of the roof and do potentially dangerous measurements. You can just do all of this beforehand. You can pre-qualify your site. You can get exactly what you're looking for in a lot less time, with a lot less risk to you, and with a lot of money saved and time saved. Not having to visit that site, not having to get up on that rooftop, not having to send someone out and be on call. So now that I've done that, now that I've designed my trees, I'm going to go to electrical here. Recenter my view a little bit, and you can see I've got these microinverters already pre-selected for my site. Now, microinverters, just like inverters, are available in HelioScope, so you can select those for your design. And I'm just going to set this max inverters per branch automatically, but I can set it manually. I can add an AC panel here and drag it off the rooftop. And I've got my point of interconnection over here, but I probably don't want to have it back at the house. It's more likely to be over here by the street, so I'll drag that over. Now I've got my mechanical keepouts and electrical design, so I can click Save and Exit here, go to Reports, and click Simulate. And this is only 16.2 kilowatts DC in size, so it is going to be pretty small. Somebody asked, can 3D models be exported to be used with PVSys? So I don't necessarily know that our models can be exported to be used with PVSys. We do have a CAD export that's coming out in 3D, but it's not going to be exporting those as surfaces, which I believe is what PVSys is looking for specifically, is for the surfaces there. But you may be able to edit that if you take that into PVSys. That said, HelioScope actually is the same quality as PVSys. So if you're looking at PVSys because your financing requires you to use it, well, maybe it's actually time to make that argument with them that, hey, HelioScope is actually delivering the same quality of simulation as PVSys, but I'm able to do it in a lot less time. I'm able to deliver these better layouts. We actually do have supporting documentation for that if you would like to take a look. Let's see. I don't know that I have the link to that directly available, but actually we can take a look at that slightly later. Now, I'm going to go into the report again. I don't want to show you the whole report, but what I do want to show you is at the bottom of System Metrics, I've got this blue View Shade Report button. And if I click into that, let's say you're working with the Oregon Shade Trust or NYSERDA or any of these other jurisdictions that are requiring you to do shading analysis for your site to get rebates. Well, you can see this is what we have worked on with them to make sure that you actually have that sort of report. So I've got a heat map of my field segments and how they're performing. I've got TOF and TSRF reported by field segment, my monthly production reported by field segment, and my nice monthly production and sources of system loss chart, as well as a southwestern angle of our roof. Now, we have worked with these jurisdictions to get you what you need for these shading reports, but hey, if you're working with hasn't begun to accept HelioScope reports, we will absolutely work with you and them to make sure that these reports are accepted. Just send us a message at support@folsomlabs.com, and we'll get to work on that to make sure that these heat maps are accepted, these shading reports are accepted, so you can deliver them shading analysis. Now, if you would like to know how to do that high-quality shading analysis that I was talking about that's going to get you that LiDAR quality or better data, Well, I'm going to put the link for how to do that into chat right now. It's called shade-based height estimating, and I highly recommend that you take a look at that if you would like to do remote shade design. All right, so I'm going to jump out of this really quickly and go through that ground mount demo. Click New Project, call it my ground mount demo. I'm going to take us to my final address type, just that general area, so Kansas City, actually where we're going to go back to, and I'm going to select default ground mount for my profile. Now, you see this takes us to the middle of Oak Street and 12th, which might not be the best place for a large ground mount project, but I do happen to know that there is a large field over to the west. So I'm going to zoom out here, and I can drag this map over to get on top of that field. And the important thing here is that I'm dragging this map while I'm actually in this project creation. If I did that while I was in the design, say dragged it 10 miles away, 12 miles away, well, I'd actually kind of telling the program that I'm designing somewhere that I'm not. And that's not exactly what we want. We actually want to get a quality design where we actually want to design. So if you want to relocate, do that here in the creation page. So now that I've got my name, my address, my file, I've relocated my map. I can create new project and create a new design to get into the designer. We've got high quality image here from Google, so it looks like we don't need to shift that around. I'm just going to start drawing out my field segment here. Click my first point, hold shift right off the bat to get that that nice absolute north-south access line, and then double click again, and I've got east-west on the top as well. And you see, this just laid out 4.3 megawatts of modules instantaneously. You can see the HelioScope is fast not just for those small-scale residential designs, but all the way up to these multi-megawatt utility-scale designs. And the thing that I want to show you most for this ground mount is, if I zoom in here a little bit, I'm laying my modules out based off of frame size. Right now that's at 4 up by 1 wide. Modules are laid out in 1, 2, 3, 4 by 1 module wide. It'll be a little bit hard to see from this view. So let's recenter that and set this to, let's say, 3 up by. And let's also give ourselves some frame spacing, so some east-west spacing in between our frames, maybe of about 4 feet. And you can now, I have these 30 module blocks of modules laid out, as well as even column spacing, as well as even row spacing. I could run that time of day row spacing to get slightly tighter because we know that we've made those a little bit shorter. They're only 3 modules high now. And you see, this is still 3.5 megawatts in size, but all these changes are happening instantaneously. We are still having a good analysis for how much space we want in between our rows for our ground mount. HelioScope makes it that easy for you to do. So now I've got this laid out. I think for keep outs, we say, hey, this building is going to be demolished. We don't need to model that. We can just go to electrical here, and I've got 118 inverters. I'm at about a 1.24 DC-AC ratio. And let's get those just to show that the system can handle it. So I can go in here, set this manually, say that I've got a string size of, let's say, 15 to 15. Really use that 30 module array. That means that now I've got 2 strings per array, so this is really easy for my contractors to go out and string for me. So now I can just click Save and Exit here, go to Reports, and click Simulate. And even though this is 3.5 megawatts DC in size, this is going to simulate in a pretty quick amount of time, maybe a minute and a half. A little bit larger, sure, going to take a little bit more time, but for those of us who have used other simulation programs, you know that that can take a large amount of time, especially for these utility projects. HelioScope, it is still fast even at this size. It looks like we may have had another question come in. Is there an option to import AutoCAD with land boundaries into HelioScope? So not specifically as a CAD file at the moment, but you can import that as an image as an overlay. So I will put the link for how to import image overlays into chat so you can actually see how to do that. But we do want to add AutoCAD import with those dimensions with terrain into the system in the future. So that's absolutely something we will be adding. Someone else asked, can bifacial modules be simulated? So right now, you absolutely can, and we do have bifacial modules in HelioScope, but that modification to the power is going to be manual. So if you are using facial modules, what you're going to do is you're going to go into the soiling losses, and you're actually going to enter that loss as a negative loss. the link for how to do that into the chat here. But we don't have the official bifacial math yet. Honestly, there isn't really official math for how bifacials do gain energy in the industry at the moment. So that is something that we are going to be working on adding to the program. We just need a little bit more, more information from labs, from respectable sources, from the financial institutions as well, what they accept for the power gain for bifacial modules to do that full modeling. Somebody else asked, can you import PDF? Not at the moment. Our overlays are JPEG, PNG, and KMZ or KML at the moment, but we will add PDF import in the future. Now, there are a few other things that I want to show you. I realize that we're going slightly over time, so I'm going to go into a little bit of overdrive mode just to try to show you all of them. First, down here in the bottom right-hand corner, if you have questions using HelioScope, you can click this questions button here, and if I say, hey, oh, there we go. Hey, I need help. This is a live chat, not just a webinar test. This is not just something that is going to be a joke. You can see, by the way, in case you thought I was Evan this whole time, nope, turns out I'm Canute. But Evan is already chatting with me. This is not a thing that we do just for a webinar. This is actually how fast our support is, because we don't want you to have to wade through bots or set up a phone call that you have in a few days to solve a problem that you're having right now. We want you to get that support right then, right when you need it. So you can see Evan's already talking to me. He can see the project that I'm working in. He can send me helpful links. I can send him my project so that we can go in and we see what's happening immediately. So instead of you waiting on support, now support is there for you when you need it. So if you have an issue, we can solve it for you right away, and you can get back to the work that you want to be doing instead of waiting on the support to allow you to do it. And if I learn anything in this chat, I can always click this end chat button up here in the top left, and I can send myself a script of the conversation. Now, let's say that's not quite your style. You want to learn something else. It's not 24/7. Right now, our hours tend to be between 8 and 5:30 PST on business days, but we are sometimes online at other times. Now, if that isn't quite your style, we've also got this documentation database. So if I go up here to the top right, I click documentation. This is our fully written out documentation help database. This is really well documented. It covers all of HelioScope. So let's say I want to know how to create a project profile. Well, I can search profile here. It looks like the first link is for project profiles, and this gives me a video walkthrough as well as written out step-by-step instructions for how to go through and create a project profile for myself. And this is for all of HelioScope. If you're curious about any functionality, we have gotten for it to help you out so you can actually really explore what is going on. Now, a few other things. If I go up here to the top right, if I go to my account, if I click that drop down, go to my account, I've got this page here where I can update my name, update my company, and also update my logo if I want to. The preferences page, I know I've been working in feet and American wire gauge, but I can switch that to meters and I can switch that to metric. In the profiles tab, this is where I can create my project profiles, but I can also set a default profile that's selected every single time that I do a design. And in third-party services, I can hook up other third-party services like Nearmap. But let's say that you want to use one of our other integrations. We actually have a number of them. We're integrated with Energy Toolbase if you want to do utility rate analysis and storage modeling. We're integrated with Homer Energy if you want to do microgrid design and battery modeling. We are integrated with Unirack. So if you have a ballasted racking system, you can actually take your HelioScope design and import that directly into their UBuilder tool to get an automatic ballasted racking bill of materials. We don't have something, we still want to be working with the best and the brightest in the industry to get you what you're looking for. And the thing is, through all of this, I haven't been doing anything that's that complicated, right? I've been drawing shapes, I've been selecting components that I know that my company wants to use, but I haven't been doing anything that's that complex. And where we really see HelioScope being worth it is for teams that have both sales and engineering. Because what's the typical sales and engineering process? You have your salesperson goes out and makes a sale to a customer that has to be brought back to engineering. They do that first design, which gets brought back to the customer who wants to make it, goes back to engineering, so on and so forth. And we all know that is a dangerous place to be. That's some place where the customer can lose interest or where competition can step in. Really, the design can fall apart for any number of reasons. The deal can fall apart for any number of reasons. But we want to reduce that amount of time. Now, if you're using HelioScope, you can see this is easy enough to use, easy enough to learn, that you can have your salespeople learn how to use this and actually do the design with the customer. Or just have pre-done designs and take them to the customer and edit them directly with them. So all of a sudden, your salesperson is going and working directly with the person who's asking for that design. And so sales is really happy because they can have pre-qualified designs. They can have really high quality leads. So of course, what salesperson doesn't want that? And your engineering team is happier as well because now they have higher quality leads coming to them. They have to do less engineering, and it takes them way less time to actually go through and make changes if there are any that come up. Maybe they can just go straight to permitting if your sales team is good enough. Customer is happier too because now they have a consultative sales process. They have someone who can sit down directly with them, and if they say, I want different row spacing, I want to see if this tree gets removed, I want different modules, different inverters, you can do all of that right away. And you can turn your turnaround time to an incredibly low value. We have people tell us regularly that something that used to take them 8 hours or 10 hours to get turned around now takes them 10 minutes or 20 minutes. That is a drastic time savings, and it just means that you can focus on other deals. You can do all sorts of incredible things now that you have all that time back, and you can spend your money on other things that matter more to your business rather than just putting it into a long engineering and sales process. And the thing is, to put the cost of this in context, HelioScope, again, is $95 a month or $950 a year. And if you say a designer's time for your company is worth $50 an hour, the cost of their salary and keeping them in an office, all that is $50 an hour, you only need to save that one person 2 hours of work a month for HelioScope to be worth it. And any time after that, that's just time you can spend on other things. Any money you save as a result of not having to buy those other expensive engineering programs, that's money you can spend on other deals. And you've got this faster process, you've got happier customers, you've got your team working more in tandem, kind of more quickly together because, hey, you decided to try using HelioScope. And I know that I kind of blew through the end there. I apologize if, and it looks like we didn't have any additional questions, but if you do have any additional ones, please feel free to use that chat box on the site or send us a message at support@folsomlabs.com. We are all in this crazy solar world together, and we want to make sure this is a good product for you. We want to offer you that support. We want to offer you that assistance. We want to make sure that we're actually getting you what you need. That's the thing. We try to keep our costs low. We are not trying to oversell you on this. We want to make sure that it is actually what you legitimately need for your business, because that's what we care about. We care about making this a good product for the solar industry and making it something that everybody can use. So without further ado, I think I'll end the webinar, but if you do have any additional questions, please feel free to send those to us. I really appreciate you staying on here for that extra time, and also for all the great questions that you asked today. So thank you again. I hope that you enjoyed HelioScope, and I hope that you have a great rest of your day.